Hello everyone, you're welcome back again. In today's tutorial, we're going to learn how to solve for the value of x from this simple Olympiad mathematics problem. And the given equation is x root of x is equal to 2. Then we're asked to solve for the value of x from this equation. So the first thing we're going to do is to rewrite the equation. We have x root of x. Then inside the square root, we have another root x, which is the same as 2. The first thing we're going to do is to remove this square root by taking the square of both sides. So we take the square of the left hand side and also we take the square of the right hand side, because in an equation, anything you do to one side, you must also do to the second side, so that this square here is going to affect all the term in this bracket. As you can see, this x is multiplying the square root, so x2 will affect this x and also affect the whole of this square root. So x raised to the power of 2 is the same as x to the power of 2, then multiply by this square is going to cancel the square root, then we are going to left with x root x, which is the same as 2 to the power of 2 is the same as 4. Now the next thing we're going to recall is to recall that when we have a raised to the power of m multiplied by a raised to the power of n, this is the same as a raised to the power of m plus n. This is one of the property of indices. When you have the same base and there's multiplication, what we're going to do is to write one of the base, then we add the two power together. So in this case, if you look at x to power 2 is multiply this x, and this x is the same as x to the power of 1. So when we multiply x to power 2 by x to power 1, all we need to do is to write one of the base, which is x, then we add the power. 2 plus 1 is going to give us 3. Then all multiplied by square root of x, which is the same as 4. Now, the next thing we're going to do, as you can see, we still have another square root again. So we need to cancel the square root by taking the square of the both sides. So we take the square of the left hand side and also the square of the right hand side. As you can see, x to power 3 is multiplying root of x. So therefore, this square here is going to affect both x to power 3 and square root of x. So x to power 3 raised to the power of 2, all we need to do is just to multiply the two power. 3 multiplied by 2 is going to give us 6. So we have x to power 6. Then this square is going to cancel this square root. So we are left with only x, which is equal to 4 to power 2 is the same as 16. So the next thing we're going to do, as you can see, this x here is raised to power 1. It's still the same. Then we apply this property again by adding the power and write one of the base. Then we have x and x, so therefore the base is x. We pick one of the base, then we add the power. 6 plus 1 is the same as 7, which is the same as 16. Now we have x to power 7 is equal to 16, and we are looking for the value of x. So how are we going to do to remove this 7 now? When we raise both sides of this equation by 1 over 7, as you can see, the power is going to cancel. So let's try that. So when we have x to power 7, all raised to the power of 1 over 7 is equal to 16. And remember, anything you do to one part of the equation, you must do to the second side. So we raise this 16 also to 1 over 7. And recall the power property of indices. When you have a power and when you have a term raised to the power and all is raised to another power, we are free to multiply the two power together. So that when we multiply this 7 multiplied by 1 over 7 is going to give us 1. The whole of this will be 1. X to power 1 is the same as x, which is equal to 16 raised to the power of 1 over 7. So from here, we are going to recall that when we have x raised to the power of 1 over y, this is the same as y root of x. This is one of the property of indices again. This property we are going to apply to the right hand side of this equation. As you can see, this is in form of this x to power 1 over y, 16 to the power of 1 over 7. So we are going to transform it into this form. So therefore, this x represents 16 and this 7 represents y. So x now will be equal to 16. So we're going to put 16 inside the square root. Then we take 7 to root of x, which is the same as 16. So therefore, this can be transformed as seventh root of 16. So this is the value of x that satisfies this equation. But if you want to know the approximation value, so when you press calculator, seventh root of 16 is going to give us approximately 1.486. So when you substitute 1.486 in place of x from this equation, you are going to see that the left hand side is going to be the same as the right hand side. So therefore, the value of x that satisfies this equation is approximately 1.486. Thank you for watching, and please follow us for more videos like this. Thanks.